research. I want to welcome everyone. Again, we have a lot to cover. If you saw the agenda today, we will be featuring our colleagues from the CVNR, and Dr. Madeleine Hackney is going to come on and tell you what you can expect. And then Dr. Parker is here. She's going to be introducing Dr. Nadine Kaslow. She's going to be talking about coping uh, with all that's going on with the pandemic and the election and just our current climate. We need some strategies. And so she's going to wrap up today's program with those tips. So we're going to dive right in because, again, we have a lot to cover. You see our lineup of presenters and speakers. John, are you on? Because every week, what do, guys? We begin with exercise, right? And Matt Doran, also, if you have been following us the last 3 weeks, we have been having a concurrent session after, I'm sorry, a session immediately after our BrainTalk Live, featuring our cognitive empowerment program with the Emory Alzheimer's Disease Research Center. So Matt is going to drop the link in. Matt, we may go over a little bit today. As you can see, we are jam-packed today. But if you can drop the link, you guys can transition from this program to CEP. I see a lot of you guys are rolling over to that program. So thank you so much. And so, John, come on in, get us revved up and ready to go, because what do we say every week? What's good for your heart is good for your brain. And so tell us what we need. We're going to dive right in. We're going to get all that we can going with our hearts. And then we're going to get our notebooks ready and our pens and get ready to take a lot of notes. And yes, last week was recorded. I need to send the link out to you all. We will share the slides as well. So take lots of notes. That way you can go back and look at the recording and the slides later in the week. Okay. All right. So with all that said, John, take us away.
Hey, first of all, I want to welcome everybody to the Emory Alzheimer's Disease Research Center. Remember, we need a sturdy chair. Hey, today we're going to work with our water bottles. If you have hand weights, ankle weights, whatever you need to grab, books, it doesn't matter. Grab them right now. Then I'm going to show you some exercises you can do with your band. But we're going to get warmed up with a little stretching. So let's get going. Feet wide. We're going to go up and down, just 5 today. Here we go. And 1, 2, 3, 4, 5, 6. Let's go left to right. Here we go. 1. Turn that waist. 2, 3. We say lower back. We're about to do some work. Good. Our next one here, hand over and stretch. 1, 2, 3, 4, 5. Switch. 1, 2, 3, 4, and 5. Good. Right leg straight. And we're going down 5 times. 1. Toe flexed up. 2, 3, 4, 5. Switch legs. 1, 2, 3, 4, 5. Good. Butterfly your legs. We're going to get them inner thighs, growing areas, and outer hips. Down. 1, 2, 3, 4, and 5. Good. I want you to turn a little bit. Bend the back knee. Then I want you to straighten it, bend, straighten it, bend, straighten it, bend, straighten it, bend. Switch to the other side. Straighten it, bend, straighten it, bend, straighten it, bend, straighten it. One more. And good. All right, let's turn that waist. Here we go. Great job. All right, if you have your water bottles, here we go. Let's get this upper body. Let's go. Boom, boom. And we're gonna get that cardio up. Come on, come on. We get that, them legs, up angle. Come on, come on, come on, come on, come on, higher. Come on, come on, come on, come on, come on, come on. Rest. There we go. Hands on your knees. We're gonna get these biceps. Let's go. One. Come on. Come on, come on. Good. Hammer style, girl. Come on. We get these biceps. Rest. Triceps. Boom, boom. Keep that elbow up. Come on. Rest. Here we go. To the side. Elbows up. Bang. Keep that elbow up. Make sure that arm is straight. 3 more. 1, 2, 3. Great job. Here we go. Halo. Come on. Get them up. Get them up. Get them up. Come on. We get them windows. We get them side obliques. Let's go. Rest. Now watch this. Let's go. Boom, boom, boom. Go, keep it going. Boom, 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 boom. Rest. Great job. Great job. Now I'm going to get that lower body. And we're going to get that core. Right knee. We're going to get one side of the abs. Let's go. Rest. Other leg. Go. Crunch, 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 crunch. Rest. Let's get your side obliques. Move it to the side. Keep this leg straight. Ready and go. 4, 5, 6, 7. Rest. Straight. Other leg at an angle and up. Let's go. 1, 2. We getting those side obliques, the lower abs, the mid abs. Rest. I want you on your toes. Now we're gonna get the side obliques. Now we really getting it. Going all the way around that spare tire. Come on. Twist. We get the hips and the obliques. We're gonna keep this one going. Let's go. Rest. Widen the leg. Now I'm gonna really engage them hips and the abs. Come on. We get those hip flexors plus that core. Inner thighs, outer hips. And we get a little bit of those ankles. Rest. One here. Pick up. Pick up. Pick up. Pick up. Pick up. Come on. Pick up. Pick up. Pick up. Pick up. Rest. Okay, I'm gonna make this leg and boom, 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 boom. Rest. Other side. Come on, crunch, crunch, crunch. Grab the abs, grab the abs. Come on. Boom, boom. If you at work, you at home, let's go. Rest. Woo. We about to get that cardio in now. Here we go. Let's go. Come on. We getting circulation, vibration in the entire body. Okay. We getting blood flow going. legs wide. Come on, hands up. I remember when I was on the cruise ship, this is what we were doing. Next week, I'm taking y'all to the islands now. Y'all be ready. Oh. Oh. Shake it up. Shake it up. Can you do two motions at the same time? Shake it up. Shake it up. Shake it up. Rest. Great job. Great job. Next week, I'm taking you to the islands, and we're gonna do something very, very special. And I want to say bye to everyone. And remember, love is always, and make sure you do something for that temple every day. I'm John Lewis, and see you later. Bye.
All right. Yes. Okay, are you ready to get going with all of this content that we are going to be covering today? That was exciting. You know, John's energy is contagious. So Madeleine Hackney is going to come on in while everyone takes a breather and catches your breath. Who knew that you could get a great 9-minute workout in from the comfort of your home in a chair? Yes. Madeleine.
That was fantastic, John. I'm energized. That was great. I need to do that every day. Just perfect. Cornelia, can I share some slides?
Okay, give me just a second to give you the remote.
I'm going to tell everyone about the VA, the Atlanta VA right here in Atlanta on the Decatur campus. Center for Visual and Neurocognitive Rehabilitation. If I can't share, that's okay. It says I can't at the moment.
Yeah,
I'll talk it through, no problem.
Okay, keep talking while I'm
Yeah, no problem. So yeah, we're the Center for Visual and Neurocognitive Rehabilitation. We're a rehabilitation R&D center. We're one of only 13 rehabilitation research and development centers in the whole nation. And we've been around for a very, very long time, since the 80s. And our mission is to improve veteran health and the quality of life in visual and cognitive disorders by engaging an alliance of researchers and clinicians to advance evidence-based rehabilitation. We have 4 cores. We have a neuroimaging core, which you are so lucky. You're going to hear all about our neuroimaging core today and some of the very exciting research that a couple of our scientists do. You'll also will hear next month, stay tuned for February 23rd, come back and meet more of our wonderful scientists who are part of the molecular biology core. We also have a fantastic administrative core that they really keep everything running. Probably couldn't do a darn thing without them. So we really owe our admin core a lot. And then we have a fantastic physical exercise core. We need to recruit John into our physical exercise core. I can tell. These cores work together seamlessly to do all kinds of wonderful studies, including exercise studies. We have studies where you get on a bike and you exercise for a long time, like over a period of a year. Also brain studies. And we have a wonderful registry. Our exercise studies also include something called partner dance, also known as adapted tango. That's actually some of my work. People with Parkinson's have participated, and also African-American caregivers for people with Alzheimer's disease have participated in the past, as well as older adults with low vision. We also do fantastic aerobic exercise interventions. Our brain studies look at aphasia treatment for those in stroke who have aphasia. We deal with spatial neglect treatment. We have specialized expertise to deal with that. Of course, just aging, what happens to the brain over a period of time, and fibromyalgia treatment as well. We have a CVNR participant registry. The purpose of our registry is to connect researchers at the Atlanta VA with people interested in participating in research studies. And if you become a member, we'll collect your name, your contact information, and a brief health history. So you can join this registry, you can volunteer for research projects, you can help improve health through research, and help veterans and veterans families. So for more information about that, you will contact Amy Rodriguez. Her phone number is 404-728-5064. We can also provide some of that information after the talks today. And we also have a website at www.barrd.emory.edu. And again, we can provide that information to anyone who wants more information about the CVNR. But now I'm going to go ahead and just briefly introduce our speakers. We have a team of 3 speakers who are fantastic and knowledgeable. The first speaker will be our CVNR staff scientist of the Neuroimaging Corps, who was recently recruited, and we are very lucky to have him. His Dr. Daniel Wakeman. After that, you'll be hearing from 2 of our seasoned CVNR investigators, including Dr. Bruce Crosson, who has more than 2 decades of neuroimaging experience, and Dr. Keith McGregor, both of whom are faculty with the Department of Neurology at Emory. So with that, I am going to let Dan Wakeman take it away.
Hi, everybody. I hear you are all experts, so I'm just going to give a quick introduction to MRI imaging, which hopefully will get everybody primed for Bruce and Keith's talks to follow. So, starting off, if we can go to the next slide.
I also gave you the remote.
Thank you.
Okay, there you go.
So MRI. For those of you who are lucky enough not to have had an MRI yet, this is what the MRI looks like. This is just a cartoon of it. There's usually a large tube like this, and you lay down on a bed and you go inside. It's a tube because it's easy to make a magnet that's a tube. And we need a very strong magnetic field in order to take images of your brain, a knee, whatever we're looking at. In our case, we are typically looking at the brain because that's mostly what we study here. So why do we use a big magnet? We all know that a large part of the human is water, over 90%. And in a magnetic field, the protons in that water begin to spin. And so they will spin around the magnetic field, and they'll also wobble around it, just like a top. If you spin a top, it'll start to wobble around the upright. So that's how the protons will start to spin. If we then play a radio signal at the same frequency, that will change the way that they're spinning, and it'll tip them over on their side, and then those protons will give off their own radio signal. And that's what we do. We listen to the radio signal coming off of those molecules, and that's how we make an image from your brain or from your knee. So we're relying on that radio signal. And for fMRI, what we do is we take lots of images. So we take an image basically every second of your brain, which is why if you come and participate in one of our studies, we'll ask you to try to stay as still as you possibly can in the scanner, because just like a picture that you would take on your phone, if somebody's running around or if you're shaking your hand, you can get a blurry image. So we try to avoid that. And we'll ask you to do something while you're in the scanner. And I'm going to go through a simple example here of showing you pictures of faces and pictures of houses. And we can then look at how the brain reacts differently to those. So what we're taking advantage of is that when blood is carrying oxygen, the way that those protons spin is different. And so we can compare the blood that has oxygen and the blood that doesn't when you're looking at faces and when you're looking at houses. So what we end up doing in the case of fMRI is doing a contrast always. We're not just looking at what your brain is doing when you are looking at faces or houses. We have to compare the one to the other. So this is an example of what it looks like. And this view over here on the left is an image from the side. And the two images on the right are from below the brain. So looking up through my chin, basically. And the blue area is called the fusiform face area. And the red area is called the parahippocampal place area. And this is a classic study. And what they do is you compare the oxygen in blood between when people are being shown faces and houses. And you end up seeing that when they're seeing faces, the fusiform face area is more active than when they're showing houses, and vice versa. So when you're showing houses, you see the parahippocampal place area light up. So we're always contrasting things in fMRI. What else can we do with MRI? The other thing we can do is spectroscopy. So, and this is something that Doctors McGregor and Crosson are going to talk about later, but we can actually measure how much of a material is in there. It takes a lot longer to take one image that way because we've got to measure it many, many, many times to get an accurate estimate of how much is there. And what we take advantage of is that each molecule will give off its own frequency response to the radio signal. So by measuring many times and listening to the whole, every frequency that comes off, we can get a measure of what the distribution is of different molecules in a region. So those are just a couple of ways that we use MRI at the CVNR. And if you're interested, please sign up for the registry. We'd love to have you as a participant. And yeah.
Hey, Dr. Wakeman, you said fMRI. Can you tell them what the difference is between an fMRI and a plain MRI? What's the difference?
So it's the same machine, but in a functional MRI, what we do is we take lots of pictures in a row of the brain and then compare different conditions so that we can see what the differences are in the brain's responses to those conditions. And the F stands for functional.
Thank you, Dr. Wakeman. I think right now we're going to move straight to Dr. McGregor. Dr. McGregor.
Hi there. Thanks, Dr. Wakeman. That dovetails really well into what I'm going to be talking about. So I'm going to be talking about some findings looking at fMRI and using this technique called spectroscopy. And my interests are essentially looking at aging-related changes in motor performance. And by motor performance, I mean both performance on tasks as well as motor learning. And I'm going to talk about that very briefly. But what I'm really interested in is the effects of physical activity on the brain, because it does change, your brain does change as a function of physical activity. I'm going to show you an example of that in a moment. And so, there we go. And so, as people get older, about the age of 25, hand movements begin to become less coordinated, and importantly, motor learning tends to slow down. Over the age of 65, these decreases in function tend to accelerate. And this is respective, and so unfortunately, this requires increased effort to be able to complete a task. There's higher error rate and slower learning. Now, what's very interesting about this is that we cannot separate the body from the brain. And so patterns of brain activity are largely responsible for describing the changes that we see in this motor function. And here on the right, you see a bit of a continuum respective of some of these different patterns associated with what we call motor learning with aspects of cognitive aging. And so some of the things that we've seen in motor learning in aging are very similar to what we see in more executive functions, such as working memory, language tasks. I'm going to show you some examples coming up. And so one of the hallmark findings that we've looked at over the years, looking at functional magnetic resonance imaging, has to do with comparisons of youngers and older adults. And this is in movements of the right hand. So as many of you know, the left hand or the left side of the brain controls the right side of the body. And so as Dr. Wakeman said, the importance is contrast. And so we're contrasting this just to rest, just resting. And so what happens when a person's moving their hand in younger adults is that they show an increase, or this bold signal, blood oxygen signal that goes up. And so that increases. Well, what happens in the opposite hemisphere in younger adults is they actually show a decrease. Now that changes as people get older demographically. And so in cross-section, our studies have shown that older adults tend to recruit or show activity in both sides of the brain. And we sort of wanted to find out, is that good or bad? I mean, the results are a little bit mixed right now. But what we have found is that as a function of physical fitness, we've seen these characteristics change. So our sedentary older cohorts in our studies tend to show this activity that we've characterized as being older in terms of activating both hemispheres. Whereas when we looked at people who are habitually fit, that are very, very fit, they tend to show activity in the right side of the brain, very similar to younger adults. And so we started to ask the question, does this mean that their performance is improved? And indeed, in cross-section, performance was associated with this profile of being more fit or showing activity more similar to younger adults. Now, this is a very busy slide. I'm sorry. I'll go quickly through it, but hopefully it's understandable. We did an intervention study with my colleague, Dr. Joe Nocera, who many of you may have seen in these talks. And we looked at essentially how does functional MRI change over time after a 12-week exercise intervention where people come in and they do spin cycling 3 times a week for up to 40 minutes. And what we found when we just looked at people at resting state, when they were just resting, is that the amount of activity on one side tended to be increase at the expense of activity on the other side. So basically you saw more left activity and a shrinkage of the amount of right side activity. And this was related, it was correlated with motor performance, basically how quickly a person could move their fingers. And so we wanted to find the question, why is that? What's going on? And so we started our current work looking at spectroscopy. And as Dr. Wakeman said, spectroscopy allows us not only to show where in the brain things happen, but also how much of a chemical exists. And so the primary inhibitory transmitter is called GABA. And so the concept of inhibition is different than the idea of brain activity or excitation. And so the brain has to tell itself to be quiet at times. And so it uses this chemical called GABA, in part with others, to essentially get to afford this. And so what we found over the years is that aging is associated with a decrease in this amount of GABA within the brain. And this might have functional consequences. And so we want to look at that in terms of, well, what's going on in terms of activity and what's going on in terms of being able to change that. And so in a preliminary study, what we did was we looked at older and younger adults. And indeed, we replicated this finding insofar that younger adults had more GABA than did older adults. And we started to relate this to how does that affect performance? In particular, learning. Learning potential is really, really important to us because, as I said before, you can't really separate motor learning from learning in general. It has the same properties. And so what we started to look at with my colleague, Dr. Krishnamurthy, is when we quantify, when we look at how much of this chemical GABA is in the brain, there's this sweet spot that it appears that it needs to reside in to be able to fluctuate in a particular pattern that allows you to learn properly. And so what we found is that older adults may be on the lower end of the spectrum. They can learn, we certainly can learn, but it's a little bit slower. Whereas individuals who's actually had a stroke, a cortical stroke, or at the upper end, they have too much GABA. And so at both ends, they can't essentially do that type of modulation that's required in order to learn. And so we decided to look at this as a function of our exercise. And we said, you know what? Exercise may be associated with a change in GABA. And so what we wanted to find out is, how does GABA change as people are learning? And this is essentially the study that we have going on now. And so what we found over, again, a 12-week exercise program is that at rest, individuals who go through the exercise program have an increase in their amount of GABA. And so this is correlated with their how well they learn a task, how quickly they're able to learn a task. And what we've also shown is that indeed the level of fluctuation, how much this GABA changes, is also correlated with how well they learn the task and how well they retain it. And so what we're trying to do now is ask the question, okay, as we collect more data, what are the differences associated with people who come in with GABA at different levels, and what are the characteristics? And so this study essentially is ongoing, and I'd like to refer you to our recruitment, which is part of our recruitment core, our registry. But with that, what I'll do is I'm going to hand it off to Dr. Crosson, who's going to talk about some of his research associated with spectroscopy as it relates to some markers of inflammation within the brain. And so, Dr. Crosson.
Dr. Crosson, are you on mute?
Let's start over again. Okay, so what I'm going to talk about is, can magnetic resonance spectroscopy detect neuroinflammation in aging and Alzheimer's disease? Next slide. The work is made possible by the Emory Healthy Aging Study and a gift from the Goizueta Foundation. So let's start with neuroinflammation. What is it? Neuroinflammation is the brain's response to harmful stimuli. It can be initiated by infection, brain injury, toxins, or autoimmunity. In Alzheimer's disease, neuroinflammation is thought to be a reaction to abnormal proteins such as amyloid and tau. Next slide. So in order to understand neuroinflammation, we need to talk about glial cells. In the brain, glial cells support the functioning of nerve cells or neurons in a variety of ways. Today, we're interested in two types of glial cells that also play a role in neuroinflammation. Those are astrocytes and microglia. Next slide. Astrocytes help to keep harmful substances from entering the brain from the bloodstream. They help regulate neurotransmission. They help regulate blood flow to the brain. They help clean up byproducts of neural functions, and they perform other functions as well. Microglia, as the name implies, are tiny glial cells that are dedicated to the brain's immune system. They help the brain get rid of toxins or pathogens and clean up dead cells. Next slide. So what do glial cells have to do with neuroinflammation? The purpose of reactive astrogliosis, which involves astrocytes, is neuroprotection and assisting recovery of injured neural tissues. In Alzheimer's disease, enlarged astrocytes accumulate around amyloid plaques. That's the abnormal protein we were just talking about. This process is thought to occur early in Alzheimer's disease. The second process is microglial proliferation, which refers to an increase of microglial cells during neuroinflammation. In Alzheimer's disease, activation of microglia appears to be a response to the accumulation of amyloid, an abnormal protein present in Alzheimer's disease. Next slide. So as Dan told us and Keith has emphasized, magnetic resonance spectroscopy uses an MRI scanner to measure concentrations of various kinds of chemicals in the brain. Myoinositol is one chemical that can be measured with magnetic resonance spectroscopy. It plays an important role in cellular growth. In the brain, myoinositol is comparatively abundant in glial cells. Hence, high levels of myoinositol could possibly be an indicator of the neuroinflammatory processes of reactive astrogliosis and microglial proliferation. Next slide. So what we did was we used magnetic resonance spectroscopy to measure levels of myoinositol in healthy young subjects, healthy old subjects who do not have biomarkers indicative of Alzheimer's disease, and healthy old subjects who are positive for Alzheimer's biomarkers. So you can see over on the left side of this graph, those are the healthy young subjects. And as you move from healthy young subjects to healthy old subjects, but ones who don't have Alzheimer's biomarkers in significant amounts, you see there's an increase just from aging alone. But when older folks do have biomarkers indicative of Alzheimer's disease, even though they're still cognitively normal, you see another increase in myoinositol. So we're wondering if those increases in myoinositol are showing us the increasing neuroinflammation with aging and with the presence of amyloid and tau proteins, which are the biomarkers for Alzheimer's disease. Next slide. So in this research, the next thing we really need to do down at the bottom is analyze data from biomarker positive patients with mild cognitive impairments. We have those data and we'll be analyzing them and writing up a paper with those soon. But we also need to validate that increased levels of myoinositol predict and or are associated with other indicators of neuroinflammation to make sure that what we're looking at is related to neuroinflammation and not some other process. Thanks for your attention.
So Dr. McGregor and Dr. Crosson, just to kind of, I know we're going fast, so I just want to get this question out here. Dr. McGregor, when you talk about GABA, exercise increases GABA and that therefore increases learning. Is that what you were saying in your retention and helps our memory?
So yes. So the preliminary findings right now show that acute bouts of exercise increase GABA. Ours is the first study to show that chronic levels of exercise or exercise over 12 weeks can actually increase GABA when measured pre and post. And so that's been associated with improvements in the speed at which a person picks up a task, which is associated with learning. So what we're trying to find out is how that generalizes, and that's our next series of studies essentially to try to see outside of the motor system, does this change in GABA, this increase in GABA, does it translate to other areas of the brain, or is it isolated? We think it's more generalized, and so we're still looking at that right now.
And Dr. Crosson, you talked about neuroinflammation and myoinositol. Does exercise decrease neuroinflammation in the brain and this protein that you were talking about, this biomarker?
Exercise is thought to have a positive impact on neuroinflammation and to prevent to some degree or lessen it.
All right. So I just wanted to make sure that we were all clear on why you were looking at this, because I think that sometimes we don't always understand it. So neuroinflammation is something that is increasing your risk for Alzheimer's, right?
Yes, and we still don't understand the causative role of neuroinflammation in Alzheimer's disease completely, but there have been recent indications that neuroinflammation does play a role in the structural changes in the brain that happen with Alzheimer's disease.
All right, I'll wait for Cornelia, but there was a flyer up about the different exercises that are at the Center for CVNR at the VA. If somebody could put in the numbers that you want us to call to learn more about these exercise studies. I've tried the number and I think it was wrong. So
I'll adjust it.
thank you.
Okay, one more question, and then Madeleine Hackney, Dr. Hackney, if you want to have any closing remarks before Dr. Parker introduces Dr. Kaslow.
Is there another question you said?
Well, several are coming in. Let's see. Okay, if increased GABA is good, why do stroke patients have a lot of it? And then what do you define as extreme exercise?
So it actually depends on where the stroke is. And so I'm sorry to, so cortical strokes are thought to have shown an increased level of GABA, and that may be a protective effect. So if the area is damaged in cortical stroke, the increased level of GABA might actually protect against what's called apoptosis, or programmed cell death, associated with increased levels of another type of neurotransmitter called glutamate. And so that what we call excitotoxicity might be the reason that you see increased levels of GABA as a protective effect. It's just the brain has an overprotective effect. Although we're still looking at essentially being able to better quantify how much and where the stroke is. And sorry, what's
the other one was what's extreme or rigorous, or what frequency and dosage of exercise is neuroprotective?
So this is a great question, and I see Dr. Hackney also smiling, because this is a very common question. So the American College of Sports Medicine recommends, I believe that the current recommendation is 20 to 45 minutes, thrice weekly, although you can check me on that if Dr. Hackney.
75 minutes a week of vigorous exercise.
And so
you're pretty much right.
Yeah. So and another question that in terms of dosage really has to do with adherence and whether or not a person will get to that. So it's that's sort of paired. So if a person, and so the follow-on question would be, what exercises would be good? And so our take is the exercise that you enjoy the most. And so something that will get your heart rate up to a working level. So above 50% of your heart rate reserve. So in a target zone where you're feeling moderately effortful, but essentially you have to enjoy the exercise. You have to make sure that that's something that you're willing to do multiple times.
Okay.
So working out and dancing with John is good.
Oh, it's so good.
Absolutely.
Oh, it's so good.
Okay, 1 minute, Dr. Hackney, closing remarks. Dr. Parker's going to introduce Dr. Kaslow.
Okay, no
and then we have a
problem.
few minutes.
Well, thank you so much, everyone, for coming to see us today. This has been great. We were really glad to have this opportunity. If you're interested in learning more about the CVNR, you can contact any one of us. We're all on Emory's website and everywhere, so you can find us in that way. We'd love to hear from you, get you involved with some of the research going on at the CVNR. It's for the veterans, but we also do recruit plenty of non-veterans as well. Thank you.
And round of applause. Thank you, CVNR. And Dr. Wakeman, put the link to the flyer in the chat, so copy and paste that while you can. Dr. Parker, go ahead and tell us what we're in for before we close out. We're going to try to get under the gun under 3 o'clock so Matt can talk about the CEP program that's happening right after this program.
Sure.
Dr. Parker?
Sure. There I go. Okay, we're really blessed, I shouldn't say blessed, we're really privileged to have Dr. Nadine Kaslow give us a little bit of her time. Dr. Kaslow is professor and vice chair of the Department of Psychiatry and Behavioral Services at Emory University, and she is the lead psychologist, leads the psychology department at Grady Hospital, and she's a former president of the American Psychological Association. And so what she's going to talk to us today is about how we cope and how to improve, I guess, how we adapt to what's going on around us, certainly during this pandemic. We've added some new stresses since the pandemic began, but I'm going to leave this to Dr. Kaslow to talk to us about it. You've probably seen her on Fox 5, any local television show, and national television shows, because she's always being interviewed. Dr. Kaslow.
Thank you so much, and I'm happy to be here. And we're going to go through the slides relatively quickly, and then I'm happy to have them shared with you. So you can go through the slides, start with the slides now. Thanks. So I just want each of you to kind of reflect for yourself about what have been the main stress reactions you've had during this time. What have been the main emotional reactions or stress reactions you've had? And we can go through the next few slides relatively quickly. I'm not going to read everything, but we can go ahead now. So as you can see, there's lots of different emotions. People feel sad, they feel anxious. I would say at the beginning, everybody seemed more anxious. Then as COVID fatigue set in, people got more sad, more frustrated, more irritable. You can go ahead with other things. Panic, more substance misuse, unfortunately, more alcohol and drugs. Lots of people complaining about problems sleeping. The more this has lasted, the more people are having symptoms like post-traumatic stress disorder. You can go ahead. And people are complaining that they're feeling unproductive, not able to work as well. Lots of loss, lots of grief, whether it's loss of people we love or just loss of things, being able to see family over the holidays. And unfortunately, we're seeing a lot more people feeling suicidal, attempting suicide, and even dying by suicide. Go ahead. And so I want to talk a little bit about what are some things that we can do to cope well. Okay. So there's sort of three main points that I want to make. The first is that we can cope well by being resilient, and I'll talk a little bit about that. Then how can we grow in response to this trauma or the series of traumas we've been experiencing? And that's what we call post-traumatic growth. And the final one is sort of how do we find meaning? Go ahead. So being resilient, there's lots of different ways to use coping strategies to help us be resilient. And one of the things that I want to highlight, and it was actually just mentioned around exercise, is there's no one right way to do this. Not everybody has to do yoga. Not everybody has to meditate. Not everybody has to walk in nature. You know, the things we keep hearing about. My main point is you have to do what works for you. And so whether it's a certain kind of exercise or it's reading or it's doing puzzles, it actually doesn't matter so much what it is. You just have to do this. You have to do things that make you feel well. And we have to reinvent wellness during this time, have to have good, effective strategies for dealing with our stress and anxiety. We can't avoid it right now, but we have to have good ways to use it. We have to deal with our grief. There's a lot of grief and deal with that. Find any way we can in the possible to stay connected to people, to support other people. And if your religion and faith are helpful to you, then certainly engaging with those is really important. Go ahead. And here's one picture of that sort of captures lots of different things that people are doing to try to manage during this difficult time. Go ahead. So through the pandemic, we've had a lot of challenges, each of us have, and how do we sort of go through those times and maintain a sense of hope? What can we do to better ourselves? What kind of personal growth can we do during these times? And how can we keep growing even when we feel a lot of pain and a lot of distress? I think we need to take active steps to do that. Go ahead. And so we need to embrace our learning and our growing. We need to find new ways to do things. Who would have thought we all knew how to start a Zoom call, or many people are learning FaceTime, or think about sort of all the things we're learning to do differently. Or I hadn't done a puzzle since I was in elementary school and doing those again. Rising to the challenges that emerge, where there are all of these challenges, and sort of doing our best to rise to them really looking at what are the stronger sides of ourselves and our communities. And that may be harder some weeks than others, that's for sure. But I think many of us are getting to know our neighbors better at these times. Sort of what is good in our community that we can build upon. Humor has helped many people get through this time, and I think is really useful, and certainly being creative. And we have to do what we can to rebuild or maybe build for the first time our community. So we have to find ways to grow from this. Um, Go ahead. It's also important to find meaning. Many of us read Viktor Frankl's book, Man's Search for Meaning, and sort of how he used meaning as and hope as a sense of purpose as a way to get through difficult times, like in the concentration camps. And I think that really being clear what matters to us, what's my sense of purpose in life, what are my values, and how am I going to follow those, can really help us get through this during this difficult time. Meaning that we have to take responsibility for ourselves, our own health and our welfare, and that of other people. That we have to be more of a we culture. In many ways, we become so much of an I culture, and it's virtually impossible to survive through this time as an I culture. We really have to be all in this together. Um, Pursuing meaning and hope in how life has changed. um, you know, Things are definitely different, but rather than keeping saying, I wish it would be the way it used to be, it's never going to be the way it used to be. And I don't necessarily actually think that how it used to be was so great in many ways. And think about some of the good things that have emerged. So, for example, my family now has brunch every Sunday morning together on Zoom. Well, we're going to continue that even after the pandemic is over, because that's been a really nice thing to do. And think about those things and find new ways to connect socially and really use those ways. Um, and also find new ways to be creative has been really helpful. I think we each need to sort of determine a why to live during such an unsettling time. Many people have said to me, why are you spending so much time providing support to caregivers in the ICUs during this time? Well, it's because my way of giving and it's given me a lot of meaning to help other people. We're each going to do that differently, but we just need to find our ways to have a meaning and a why in our lives. Go ahead. So remember that we've had lots of difficult times in our lives. We've gotten through them. We can do that again. That we can also if get through this by being clear about these are the things that really matter to me, and I'm going to put my time and attention and focus on these kinds of things, because the more we can maintain a sense of hope even in these difficult times, the better off we're going to be able to do with our stress and going forward. Go ahead. So think about your own strengths. What do I have? What do I bring to this table? What did I do in the past when things were tough? What skills did I use and capitalize on those? I also think this is really a time to appreciate the small things in life, the little things people do, expressing our gratitude toward other people for those small things. Notice the flowers that are blooming. Really pay attention to much smaller things. Notice it and express appreciation and gratitude for it. Go ahead. I think that we really need to find ways to nourish social support, to get it for ourselves, but really to give to people, to check in with people. People did this a lot more at the beginning of the pandemic, and then people sort of had gotten tired. And I think really reaching out, extending a loving hand, being as compassionate as we can toward ourselves and toward other people. I think compassion is one of the main names of the game during this time. None of us can do things as well as we used to, or we're overwhelmed, or we're stressed out. Being nice to ourselves and also being nice to other people. Go ahead. And so this is one of the quotes that has spoken to me the most during this time. Um, People keep talking about when are we going to go back to normal. I don't think we ever want to go back to normal. I think we need to go forward to a new normal. We will not go back to normal. Normal never was. Our pre-coronavirus existence was not normal. other than we normalize greed, inequity, exhaustion, depletion, extraction, disconnection, confusion, rage, hoarding, hate, and lack. We should not long to return, my friends. We are being given the opportunity to stitch a new garment, one that fits all humanity and nature. And so I really think that part of what we need to do right now is really find a way as individuals and as a community to create a new normal, one that we love for ourselves and for future generations. Go ahead. And so I want to just thank you for inviting me and just remind people of the importance of caring and connecting during this time. And I want to acknowledge the Caring Communities team that we've pulled together at Emory to support caregivers during this very challenging time. Thanks, and I'm happy to take any questions or comments.
Is the Caring Communities only for Emory?
No, we've been doing Caring Communities things outside of Emory for sure. And we have a website that has a lot of tip sheets and wellness guides, and we're happy to offer other services, educational services and support services as well.
So the website is called www.caringcommunities.com or something?
No, the website, why don't we get another question and then I'll get you the website.
You spend a lot of time talking about looking inward. A lot of the people who have talked about coping were using a lot of external resources. And I do appreciate that you're like, let's focus on yourself. That's something that we haven't really heard a lot of, and I think that that's a different way to look at it, because a lot of us have responded to the stress of the pandemic by what's the call line, what's the this and what's the that. And you're a little bit more, let's be a little bit more introspective.
Mm-hmm. Well, I think we do need to be, let me just see. Actually, if somebody could send that out to everybody, I sent it out to the panelists. If somebody could send that out. Yeah, I mean, I do think, that link I just posted for Caring Communities. I do think that we have to control our own destinies here in connection with other people, but I don't think we can just go out there for help. We have to find a lot of it inside ourselves. I mean, you were mentioning, the question came up about exercise, and I could not agree with you more. I mean, I started doing ballet when I was 3 and been dancing since then. And for a period of time said, oh, I should try these other things. They're better for cardio or they're better for my upper body strength. But I didn't really like doing them. And so an exercise that might be better for this, but I'm not going to, is not nearly as good as the one I will do every day. And I think that's true for all of this. It's knowing who we are and doing things that bring us pleasure and help us in even small ways during this time.
Okay. Well, we have 1 minute left. And so, Matt, I'm going to turn it over to you very quickly to give us your elevator pitch.
Hi, everyone. I'm Matt Doran. I'm the tech specialist from the Emory Cognitive Empowerment Program. Like we mentioned earlier, right after BrainTalk Live in 1 minute, we are about to start our weekly CEP Community Live. This week, we are joined by Dr. Felicia Goldstein and Dr. Casey Vickers. They are on the neuropsychology team within CEP. And today they're going to be talking about what is MCI, and they're also going to be talking about neuroprotective things that you can do in your daily lives. So like kind of different behaviors that you can start doing and to get you cognitively stimulated and physically active. And that's what we're going to be talking about in 1 minute. I'm actually going to be leaving BrainTalk Live right now to go start that meeting right now. And I also posted the registration link in chat here. So if you'd like to join us in a few minutes, please click on that link and register and come meet us over there. See you guys soon. Bye.
Thank you, Matt. So Dr. Parker, anyone else, any closing words? Dr. Kaslow, they're asking for you all to come back. CVNR, they're saying what an excellent presentation. I know any of these speakers, presenters, are experts. We could do one whole session just on each of these topics, but we try to pack a lot in a short amount of time, and you can always go back and look at the recording, and we will send out a PDF of the slides.
We'll have you back. Thank you all, Dr. McGregor, Dr. Wakeman, Dr. Kaslow, and Dr. Hackney. Thank you so much for taking the time for us today.
Bye-bye.